So now we want to look at solving absolute value equations and absolute value inequalities. So first thing that we know, and what is stated in front of us, is equations involving absolute values. If A is a positive real number, and if U is any algebraic expression, then we can say that the absolute value of U equals A is equivalent to the following. So let's just think about this for 1 second. Let's look at a real example. If I had the absolute value of 5, hopefully all you know that that is equal to 5, right? When we're looking at absolute values, we're looking at the distance between 0 and that number on the number line. It's always a positive number. If we look at the absolute value of -5, though, that distance between 0 and 5 on the number line is also 5. And so notice there's two different solutions that give us back +5. It's itself and the negative of itself. And so for this equations involving absolute value, if we have the absolute value of A, then we can rewrite this as two separate equations. We can drop the absolute value and say either U is equal to A or U is equal to the negative of the other side, -A. So steps for solving absolute value equations with one absolute value. So if we only have one absolute value, then we're going to do the following. So let U be the algebraic expression inside the absolute value bars and A be any positive real number. So we have to make sure that the other side is positive, because if we take the absolute value, we're always getting back a positive number. So if we have an absolute value equals a negative number, we can stop and we don't need to go through and solve it. There's no solution. Okay, so step one, you're going to isolate the expression containing the absolute value so that we get the absolute value is isolated is equal to the other side, everything that isn't inside the absolute value. Once we've done that, we can rewrite the absolute value equations as two separate equations. We're going to take what's inside the absolute value, set it equal to the negative of the other side. And in addition to, we're also going to set U, what's inside the absolute value, equal to the positive of the other side, where U is the algebraic expression in the absolute value symbol. And then we're going to just solve each equations. And then we need to verify our solution. So it's possible that our solution doesn't work back in the original. So this first example, we have the absolute value inside the absolute value, that algebraic expression is C minus 15. And then outside the absolute values, we have equals 23. So first step, it's already done for us. The absolute value is already isolated. And so the next step is setting what's inside the absolute value, which is C minus 15, equal to the negative of the other side. So negative 23, or C minus 15 is equal to the positive of the other side, which is 23. So we want to solve for C in each case. So we're going to add 15 on both sides. So adding 15 to negative 23. So that would give us back -8. So C is equal to -8. If I add 15 to both sides, on the other second equation, I would get C is equal to 23 plus 15. So that's 38. So we want to check. If we go back in here and plug this in for C, would it work? Is -8 minus 15, that absolute value, equal to positive 23? Yeah, because -8 minus 15 is negative 23. Now take the absolute value, it's positive 23. If I plug in 38, I got 38 minus 15, that's positive 23. So the absolute value of positive 23 is equal to 23. Okay, so our solutions work, we checked them. The next example, we don't have everything, the absolute value isolated, so we need to do that first. And it tells us to solve the equation, the absolute value of 5 minus x outside of the absolute value is plus 8 equals 1. And so to isolate that absolute value, first thing that we want to do is we want to subtract 8 on both sides. And so I get absolute value of 5 minus x is equal to 1 minus 8, which is negative 7. So we got to be careful here because, again, if we take an absolute value of a number, it always comes back positive. And so this, in this case, is no solution. If you had gone through and you set what was inside the absolute value equal to the positive and the negative side, and then went back to check your answers, you would have seen that it was false. It wasn't a true statement. And so if you didn't recognize that this was a negative, an absolute value can't be negative, and there's no solution, then when you went back to check, you would have found that there was no solution. So in this next example, we have the absolute value of 9x minus 4 in the numerator, and then all over 5x minus 3 in the denominator, and our absolute value symbols, and this is equal to 2. So our absolute value is already isolated. And so we are just going to set what's inside the absolute value, the expression 9x minus 4 all over 5x minus 3 equal to the positive and negative of the other side. So that's either equal to 2 or 9x minus 4 all over 5x minus 3 is equal to negative 2. So we have a rational equation. We can clear our fractions because it's an equation by multiplying by our LCD on both sides. So we're going to clear the fraction by multiplying both sides by 5x minus 3. So our fraction goes away on the left-hand side, and we're left with 9x minus 4 is equal to, so let's distribute that 2 to the 5x minus 3. So distributing the 2, we get 10x minus 6. Variables on one side, constant on the other. So let's subtract 9x on both sides. So that would just give me x here. And let's add 6 to both sides. So negative 4 plus 6 is 2. So x is 2 for that first equation. The second equation, same idea. We want to clear the fraction. Again, the denominator. Least common denominator is the denominator 5x minus 3. So we get 9x minus 4 on the left. This is equal to, let's now distribute the negative 2 to the 5x minus 3 quantity. So that would give us negative 10x plus 6. So I'm going to add 10x to both sides. I have a 10x plus a 9x. That's a 19x is equal to, and I'm adding 4 to both sides. So 6 plus 4 is 10. And let's divide both sides by 19. We got x is 10 over 19. So we want to check. So when x is equal to 2. We're going into our original equation and we're plugging into wherever we see an x, and we're going to see if that is a true statement. Oops. So we have 9, I see an x, so parentheses, minus 4 all over 5, I see an x, so put parentheses, minus 3. Is this really equal to 2? So let's plug in 2 wherever we saw an x where we put parentheses and see if this is a true statement. So we have the absolute value, our numerator, order of operations, multiplication first, treat numerator as a parenthesis. So 9 times 2 is 18, minus that 4. So we have 14 in the numerator, all over our denominator. 5 times 2 is 10. 10 minus 3 is 7. So I have 14 sevenths. The absolute value of that is that equal to 2. Yeah, the absolute value of 2 is equal to 2. So x equals 2 works, and that's part of our solution. And so now we got to go in and plug in 10/19. So go through wherever you see an x in your equation, put a parentheses. So you have 9 parentheses minus 4 all over 5 parentheses minus 3, that absolute value. If we plug in 10/19, which is not as pretty, right? Is this a true statement? So we basically have this complex fraction, fractions within fractions. And there's a couple of ways that we can deal with this to make it so it's not complex. I personally like to multiply by a fancy one to clear my denominators. And I multiply by the LCD of the fractions within the main fraction. And so looking at this, my LCD is 19. I'm going to just rewrite this a little bit because 9 times 10/19, this is the same thing as 90/19 minus 4 all over. And I'm going to rewrite 5 times 10/19. This is 50/19 minus 3. So let's multiply both the numerator and denominator by a fancy one. And our fancy one in this case is 19 over 19. So when I distribute 19 to this 90 over 19, that's going to cancel the fraction. And I'm going to be left with just 90 minus, when I distribute the 19 to this 4 though in the numerator, I get 19 times 4. So 90 minus 76 is left in our numerator. All over. If I distribute 19 to the 50 over 19, 19's cancel and we're just left with 50 minus 3 times 19, which gives us back 57. And that absolute value is this equal to 2. Well, 90 minus 76, that is 14. All divided by 50 minus 57, which is 7. The absolute value of 14 over 7, is that equal to 2? Yeah, absolute value of 2 is equal to 2. So x equals 10/19 also works. And so we have two solutions. We have x equals 2 and x equals 10/19. And just looking at the homework and how they wanted you to write your solution, they're asking you to put your solution as a set. And so our set, and we're going to use a comma to separate our answers. And so our set, our solution set is going to be, I'm just going to go smallest to largest, but you don't need to, 10/19, comma 2, and your curly brackets. Those curly brackets, that's what I call them. I don't know the official name, but those curly brackets, those represent sets of numbers in mathematics. Okay, so one more example. We have the absolute value of x squared plus 3x minus 9, and that absolute value is equal to 9. So we have the absolute value already isolated. So we're going to take the expression inside the absolute value, which is x squared plus 3x minus 9, and set it equal to the negative of the other side. So negative 9. The other equation, the that could satisfy this is x squared plus 3x minus 9 equals the positive of the other side, which is 9. So notice in each case, these are quadratic equations. So we solve quadratic differently than linear. So we want to get everything to one side of the equal sign. And so for the first equation, if we add in 9 to both sides, we get x squared plus 3x. Well, negative 9 plus 9 cancels. So this is equal to 0. We can factor this. They both have an x in common. So factoring out an x, we get x times x plus 3 is equal to 0. Set each factor equal to 0 and solve. We got x equals to 0. X plus 3 equals 0 when x is negative 3. Same sort of process for the other equation. It's also quadratic, so we want to set it equal to 0. So let's subtract 9 on both sides this time. And so we get x squared plus 3x. Well, negative 9 minus 9, so that gives me minus 18 here, equals 0. So we're thinking to ourselves, are there two numbers that multiply to negative 18 and add to positive 3? Well, 6 times 3 is 18, and 6 times negative 3 is negative 18. 6 plus negative 3 is 3. So x plus 6, x minus 3. Set each factor equal to 0 and solve for x. So x plus 6 is 0 when x is negative 6. And x minus 3 is 0 when x is equal to 3. So we have possibly 4 solutions. If we go back in here and plug in 0 wherever we see an x, I see right away I have the absolute value of negative 9, and that is equal to 9. So this one checks. Fortunately, the other ones aren't as easy. So let's go in, put in parentheses wherever we see an x, and then go rewrite it with the different answers we have and put those inside the parentheses. So if we're looking at x equals negative 3, oops. So x equals negative 3. So we have inside our absolute value, this case, negative 3 quantity squared is 9, plus 3 times negative 3, that's minus 9. Minus 9, does this equal 9? It does, because 9 minus 9 is 0. And so we have the square root of negative 9, that is equal to 9. So x equals negative 3 works. So now we want to check x equals negative 6. So we're going to go back in, and wherever we see an x, we're going to put parentheses. Now we're going to rewrite it with negative 6 inside the parentheses and simplify. So if we square negative 36, we get back positive 36, the absolute value of this, plus 3 times negative 6, so really minus 18 minus 9, that absolute value is that equal to 9. Well, 36 minus 18, that's 18 minus 9. And I see 18 minus 9 is positive 9, absolute value positive 9 is 9. The last case we want to look at is when x is 3. So go back to the original equation, put in parentheses wherever you see an x, and then go in and put in the 3 inside the parentheses. So plugging in 3 wherever we see a parentheses and simplifying. So we have the absolute value of 3 squared, which is 9, plus 3 times 3, which is 9, minus 9. Is that absolute value of that, what I just said, equal to 9? Well, 9 plus 9 is 18. 18 minus 9, that's the absolute value of 9, which is equal to 9. So this one also works. And so the example we just did has 4 different solutions that satisfy that inequality. Okay, so next class period, we will look at absolute value inequalities. And then we're going to get into applications on the material that we've been looking at in this chapter 1, solving equations.